Hey guys, this is question MM097 in the Maths Methods Sharpened Study Guide. The cubic function g of x is given by g of x equals a times bx takes c all cubed plus d, where a, b, c, and d are real numbers. The following is known about the function g of x. The point of inflection occurs at -3, 4. So we know that there's a point of inflection because this is in power form. So this is similar to the quadratic turning point form, but for cubics. And whenever a cubic is in this form, it makes a regular cubic, which is a point of inflection. So there's a point of inflection there. The x-intercept occurs at x equals -5/4, 0, and the y-intercept occurs at 0, 35/2. So we just need to sub in these values and try and figure out a, b, c, and d. So let's start with the point of inflection. So we've got g of x is equal to a bx takes c cubed plus d. So this is very similar, like I said, to the turning point form, where the point of inflection occurs at CD, which means that if we know that our point of inflection occurs at -3, 4, our function has to be a times bx plus 3, because it's always the negative version of this that's the point of inflection, plus 4, because that's the positive version of that. Easy. So we already know what c and d are. So that should be pretty straightforward. And now we can use our other points to work out what everything else is. So let's start with the x-intercept. So we have a point -5/4 and 0, which means that if we sub it in, we get 0 equals a times b -5/4 plus 3 cubed plus 4. So what we get is we take 4 to the other side, which means we get -4. Divide both sides by a, so we get -4 over a equals -5b over 4 plus 3 cubed. And when you see this, you'll realize that this gets very, very complex quite quickly, because if we cube root both sides, we're going to get over the cube root of a and all that sort of stuff. So this is the stage that you would sort of take a step back and try and insert the other coordinate and see if it's any easier, because we might be able to use the third point to find out what the second point is. So let's do that. I just want to take you through the process that you would go through if you were doing this question. So let's restart with this. So we've got g of x equals a bx plus 3 cubed plus 4. This time let's sub in the y-intercept. So we've got 35/2 equals a 0 plus 3 cubed plus 4. So then we've got 35/2 minus 4 equals a times 27, because 3 cubed is 27. 35/2 minus 4 is the same as 35/2 minus 8/2, which is 27/2, equals 27a. Divide both sides by 27, these two cancel, and we get half equals a. So a is equal to a half, which means that we can now put this in over here, and we get g of x equals 1/2 bx plus 3 cubed plus 4. Awesome. So now would be the time when you would sub this one in, because we've got all of our extra values and it might be a little bit easier. So we've got we've got -5/4, 0, which means we've got 0 equals 1/2 -5/4b plus 3 cubed plus 4. Awesome. So taking -4 to the other side, we get -4 equals 1/2 -5/4b plus 3 cubed. Divide both sides by half is the same as timesing by 2, so we get -8 equals -5/4b plus 3 cubed. We cube root both sides, which means we get -2, because the cube root of 8 is 2, so the cube root of -8 is -2, which equals -5/4b plus 3. Taking away 3 from both sides, we get -5 equals -5/4b. And if we divide both sides by -5/4, -5 divided by -5/4 equals b. And that means that b is equal to -5 times 4 over negative 5, which is equal to simply 4. And that's literally all we have to do. So we've got our B value, we've got our C and D. So now our final answer is to actually state what A, B, and C are, because that's what the question's asking for. So I would say A is equal to a half, B equals 4, C equals, now be careful here, C is actually equal to negative 3, because in the function we're given bx take C, and that ends up being bx plus 3, which means that C has to be a negative 3. So C equals negative 3, and D is equal to 4, which is this value here. So this is your final answer.